Alright, so last video we talked about the smoothing methods, including the simple moving average and also the exponential smoothing method. And for these methods, we need a standard to compare which smoothing method is better for this time series, right? So that's why we need to kind of calculate the error, which is also called the residuals, right? So we want to have the residuals as small as possible, and that means our smoothing method is good enough. All right, so remember that our residual is the observed value minus the predicted value, right? So here we still use it with the same name of predicted. All right, so it is still observed value minus the predicted value, and this is the residual, which is also we call the error. Right, we want the error as small as possible. All right, so we have already learned about before exam 2, we talked about simple regression, multiple regression. We use MSE to compare which model is better, right? Which model has the smaller MSE, then that model it will be better, right? So actually this is the formula of MSE, which is the observed value minus the predicted value, which is the residual, right? So we have the residual squared and then get the average of that, right? So we call it as mean squared error, right? So the error squared, and then I get the sum of this divided by how many of them, so it will be the mean squared error, right? So this is MSE, but MSE has a problem that we see in the simple regression. We had the transformation problem, right? So we cannot use the MSE for different unit. And also we say this is yt minus yt hat is the residual, and we squared it, right? So if you have a large error, this MSE is kind of penalized the large error because it gets squared, so it will be even much larger than itself, right? So that means this MSE has its own disadvantages, right? So first is about penalize the large error, and also we need to keep the same unit. If they are not in the same unit, you cannot compare the MSE, right? So to improve this, we have the next standard, we call it is MAD, right? It is MAD. So what is MAD? Is the mean absolute deviation. Right, so since we say, okay, MSE penalized the large error because we got square of it, then what about I don't square it? I take the absolute value of the residual. Then I don't have the penalty for the large errors, right? So we kind of solve the first problem. All right, so this will be the MAD. Right, we solved the first problem, but we still have the problem with the unit, right? So we still have the unit. So how we can solve this problem? We introduce the next one, which is MAPE, which is the MAPE, right? So what is MAPE? MAPE is short for the mean absolute percentage error, right? So since, okay, we get the absolute value, so we do not penalize the large errors, and we also want to solve the unit problem. So if you divide the yt at the bottom, that means the unit here, you have the unit here, divide by a unit, then these two units will be cancelled, right? And then you do not anything related with the unit, and also you don't penalize the large errors. Right, so for this case, MAPE it normally is the best way to compare the residuals for the prediction or forecasting in time series. Right, so what is the map here? Look at that, you have the YT, which is the observed value, minus predicted value, which is the residual, right? The absolute value of that divided by the absolute value of the observed value. And then how many pairs you have, you just the sum of all these terms together and then divide by n. So this n is not the sample size anymore. This n will be how many pairs of YT and YT hat. Alright, so why we say this? Let's go through a simple example. Alright, so you will have this kind of practice in the assignment 1 and assignment 2. Alright, so okay, so let's just go through a simple example. Alright, so I have a time series. Right, so I just have 3 observations, which is for 2017, 2018, 2019. All right, and then for 2017, this is about, let's say, the production of, let's say, masks. All right, and let's say in millions. Alright, for a factory. Alright, and let's say 43 for 2017 and a little bit increased for 2018 and for 2019 increased a little bit more. Alright, so this is my time series. I only have 3 observed value for the production. Alright, so what is this 2017, 2018, 2019? This is the time t, right? And then you have the corresponding y value at the time t. So this line will be y of t, right? Okay, so now let's calculate first. Let's change a color blue. All right, so let's say I want to calculate the we learned 2 methods, right? The first method is for the simple moving average method, right? So short for MA, right? And for this method, we need to specify the L, right? So here, let's say L equals to 2, right? So we want to calculate for this method with this method, that means L equals to 2. Alright, so if you want to make the predictions, you first need to calculate the estimated value at time t, right? So let's talk about what is the estimated value for 2017 from the beginning, right? By the formula, it means if L equals to 2, that means we need to average the previous 2 observations including this point, right? So that means if you want to get the estimated value of 2017, you need to average the observed value of 43 and the observed value in 2016. Right, so since we do not have any value for 2016, then that means you cannot get the average of 2, right? So for this case, it's not applicable. All right, so let's just draw one more row here for the estimated value of y of t. All right, so first, for this part, it is not applicable. All right, so what about next year? 2018. By the formula, 2018 estimated value will be 58 plus 43, right? Because L equals to 2, we need to average these two, right? So it will be 43 plus 58 divided by 2. If you calculate this, it will be 50.5. All right. Okay, what about for the estimated value for 2019? So here is 50.5. If you want to get the estimated value of 2019, that means you are averaging these two, right? So it will be 58 plus 107 divided by 2, which is 82.5, I think. All right. Okay, so here is 82.5. Do you have the estimated value for next year, which is 2020? No, because you don't have the observed value here. So theoretically, if you want to get the estimated value of 2020, you need to get these two average, right? Okay, but you don't have that value, so we only have these three estimated, actually these two estimated value. All right, so then based on the estimated value, we can get the predicted value, right? So what is the predicted value for 2017? By the formula, if you want to make the prediction of 2017, you need to use the estimated value of 16, right? 2016, but you do not have this estimated value, so not applicable, right? Okay, so what about next year? What about the predicted value of 2018? It will equals to the estimated value of previous year, so which is 2017, right? Do we have the estimated value for 2017? No, right? So it is also not applicable. All right, so what about next year? What about the prediction for 2019? It will equals to the estimated value for 2018, right? So do we have the estimated value for 2018? Yes, right? So this is 50.5, so that's it, right? So the predicted value for 2019 is just a 50.5. What about next year, 2020? Do we have this predicted value? By the formula, A equals to the previous year's estimated value, right? So it will be 2019. Do you have the estimated value of 2019? Yes, right? So which is this 82.5. Right? So if we use the table to show the relationship, that means you need to change, since you don't have the value here, so you don't have here, you don't have this, you don't have here, we have the estimate value. You can use this for the prediction value, and then since you have this, you can use it for the prediction value, which is 82.5. That's it. Right, so the next row is for the predicted value. All right, so got the idea. If you want a more kind of a little bit complex example, there is a video in the in our chapter module. Right, so if you go to the Canvas and then go to the module 5, which is the time series, and then by the end of this page you will see the two videos. The first one is for calculate the moving average method. Right, next one is to calculate the MAP, which is to compare which model is which method is better. Alright, so this is about the moving average method, right, which is the simple moving average method. Right, so now next, let's use the same data. Right, so now we have 2017, 2018, 2019, and then we have 43 here, 58 here, 107, which is exactly the same data we had here. Right, okay, now we do not use the simple moving average method. Instead, we use the exponential method, right, just a short for exponential method. Right, so we know that if you want to use the exponential method, you cannot define L. Instead, you need to define alpha. Right, so here I want the exponential method with alpha equals to let's say 0.75. Right, so this alpha will always be given to you. Alright, and then next, if you want to make the prediction, you always need to calculate the estimated value, right? So first we need to estimate it, get the estimated value for 2017. Alright, so do we have the value for the estimated value of 2017? The answer is yes. Right, since it is the biggest difference between the exponential method and the simple moving average method. Right, for the simple moving average method, if L equals to 2, that means you don't have the first one. If L equals to 3, that means you don't have the first 2 because you cannot get the average, right? But for the exponential method, the first, let's just use YT and then just create another 2 rows. The first row is for the estimated value, the next row is for the predicted value. Alright, so since you don't have the first one, you need this one to get to the next one. Remember, our formula is what is the estimated value of at time t equals to alpha times the current value plus 1 minus alpha times the previous estimated value. Right, so we need to set the first starting point. Right, so what is the starting point? Will be just the observed value for 2017. So we just use the first observed value as a starting point. Alright, okay, and then we will use this for this part. Alright, so let's continue. What is the estimated value for 2018? If you want to get the estimated value of 2018 by the formula, you need to use alpha, which is 0.75, times the y of 2018, right? So let's just use alpha here for example. So alpha times the current value, which is 2018, right? So if we are calculating the estimated value for 2018, then you need to use the current value, which is 2018, for the observed value, and then plus 1 minus alpha times the y estimated value for the y of the previous estimated value, which is t minus 1, which is 2017. The previous estimated value. Alright, so now we just plug in the number. Alpha is 0.75 times the current value of 2018, which is just this 58, right? Then plus 1 minus 0.75 times the previous estimated value. So what is the previous estimated value? Is this 43. Alright, and then after you calculate this, the estimated value of 2018 will be 54.25. Alright, so this is for 2018. Next, what is the estimated value for 2019? The same thing, right? So let's just enter the value for the estimated value for 2018, which is 54.25. Alright, okay, so next, the estimated value of 2019 will be alpha, which is 0.75 times the current value. So now current value will be 107, right? So YT, so it will be 107 plus 1 minus alpha, which is 0.25 times the previous estimated value, which is 54.25. Right, so be careful here. You need to use the previous estimated value, which is this value, not 58. 58 is YT, is not estimated value. Alright, and then after this, it is equals to 93.8125. Alright, so 93.8125. Alright, so we're done with the estimated value. Why we don't have for 2020? Because you don't have the current value then, so you cannot calculate the estimated value for 2020. Alright, and then next we'll need to get the predicted value for each year. Alright, so do we have the predicted value for 2017? Remember, we need to use the previous estimated value to make the prediction for the current value, right? So since you don't have the estimated value for 2016, you don't have the predicted value for 2017, right? But for 2018, since you have the previous estimated value, you have 43. For the predicted value for 2018, the same thing. The predicted value for 2019 will be the same with estimated value for 2018. Right, so it will be 54.25 here. So what is the predicted value for 2020? Will be just this, right? So it will be 93.8125 will be the predicted value for 2020. Right, so this is why for the smoothing method, we can only make the prediction or the forecasting for the future only for one time period, because after 2020, you do not have any further information to calculate the next predicted value. Alright, okay, so here be careful about the difference between the simple moving average and the exponential method. For the exponential method, you need to calculate from the beginning, and then for each of them, it will be used for the next one. You will need to use this one for the next one. You need to use this one for the next one, next one, next one. So you cannot get this except you calculate the previous ones, right? But if I only want the predicted value for 2020 based on a moving average method, do you need to calculate these ones? Actually, no, you only need this value, right? You only need this 82.5 for the prediction of 2020. So actually, you just need to average of these two to get the prediction. But for the exponential method, how you get this. If you want to get this, you need this value. If you want to get this, you need this value. So actually, if you want to get the prediction for the 2020, you need to calculate one by one for the exponential method. All right, so we use this example to calculate the predicted value, right? It's based on these two methods. All right, then I want to talk about how we can calculate the MAPE for each case. Right? Okay, so remember the MAPE is the way that we calculate the residual, right? So actually we want the sum of yt minus yt hat divided by yt. All right, so this is the formula of MAPE. And then how you can calculate for this case, for our case in this example. Right, so first, MAPE, the MAPE equals to 100 times 1 over n. So for here, I don't know this n yet. I just need to check how many pairs I have in this parentheses. Right, so I just keep it blank here, and then see how many pairs of yt and yt hat. Right, so let's check. Right, so for this line is yt, the green line is yt hat, right? So do you have any pair for 2017? The answer is no, because you don't have the value for yt hat, right? Okay, do you have any pair for 2018, yt and yt hat? No, because you don't have this, right? So do you have the pair for yt and yt hat for 2019? Yes, right? So the yt is 107, yt hat is 50.5. Do you have the pair for 2020? No, because you don't have yt, but you have yt hat, right? So you cannot find this pair. So actually, after you check for each year, you can only find one pair of yt and yt hat. Then in this parenthesis, it's just the absolute value of yt, which is 107 minus yt hat, which is 50.5 absolute value, divided by yt, which is 107. All right, so that means in this parenthesis, you only have one pair. Then what is n? 1. All right, so after you calculate this, you should have 100 times 1 over 1 is 1, so it would be 0.5280, so it will be 52.8. So this is the percentage of the residual, the error. All right, okay. So this is the MAPE for simple moving average method with L equals to 2. All right, so this is the way how you get the MAPE. Right, next, let's check how to calculate the MAPE for the exponential method. All right, so the same thing, MAPE will equals to 100 times 1 over n sum of yt minus yt hat divided by yt. All right, okay, so again, it equals to 100 times 1 over n. We don't know this n yet, right? We need to check how many pairs we have, right? So for 2017, do you have the pair? No, right? So you don't have the value for yt hat for 2017. Do you have the pair for 2018? Yes, right? So for 2018, the term will be yt, which is 58, minus yt hat, which is 43, divided by 58. All right, and then let's check for 2019. For 2019, do you have the pair? Yes, right? So that means you have another term, which is 107 minus 54.25 divided by 107. All right, and then here this is the sum, right? So you need to sum up all these terms. Why I close it? Because for 2020, do you have the pair? You don't have the pair. Although you have the yt hat, you don't have the observed value yt, right? So we only have these two terms. Then what is n here? Will be 2. All right, so after you calculate this, it will be 100 times 1 over 2 times 0.7516, and then MAP will be 37.58. So this is the MAPE for the exponential method with alpha equals to 0.75. Right, so based on these two methods, which method is better? Which one? The MAPE for the simple moving average is 52.8, right? And then for the exponential method is 37.58, right? So we want the residual to be as small as possible. The smaller, the better, right? So that means this method for this time series is better, right? So you may ask that, is the exponential methods always better than the simple moving average method? Of course not. It depending on how you choose this parameter, right? So if you choose alpha equals to, let's say for example 0.45 or 0.65, the MAPE will be changed, right? So nobody will, you cannot say always, all right? Okay, so it depending on how you set the alpha and L, right? So this is the way how you compare the method. But for our setting, L equals to 2 and alpha equals to 0.75, and then we calculate MAP for these two different methods, and then we can have the conclusion that based on this time series, the exponential method is better. All right, so this is the example for the simple moving for the smoothing method, right? So we are totally done with the smoothing method. In the next video, we will talk about the next class of modeling the time series, which is the regression based modeling. All right, so see you in the next video.